morning. Welcome, everybody. Thank you so much for joining us for the CalTestBed information session featuring our partners over at UC Berkeley. I'm really excited that Fred's going to be joining us today to talk about some of the capabilities at UC Berkeley. Our application period opened on February 25th, and it is going to be open until 11:59 on March 19th. So my name is Tenley Dahlstrom. I'm the director of the CalTestBed program over at New Energy Nexus. The program is funded by the California Energy Commission, and it is funded through electric program investment charge funds. So we are delighted and grateful to the CEC for providing the funding for this effort. Today, what I'm going to go over is, here's our brief agenda. I'll do a quick overview of the CalTestBed program and what it is. I'll talk about the eligibility for the program, how the application and selection process, or how the program works overall, and then the review and selection process for voucher recipients. Then I'll go over the application timeframe and then discuss a little bit about the agreement structure. And then at the end of my presentation, I have a few key resources and links that will be helpful to applicants. So the CalTestBed program, as I mentioned, is a California Energy Commission program that is intended to support mid to later stage clean energy innovators in the state of California. They provided New Energy Nexus with an $11 million grant, and $8.8 million of those dollars are going out in CalTestBed vouchers, which will provide between $10,000 and $300,000 to clean energy innovators in the state of California to test at one of our 60 test beds across the state that are located at 9 University of California campuses and Lawrence Berkeley National Lab. I really would like to emphasize our partnership with the University of California Office of the President and emphasize how grateful we are to be partnered with them, and also our fabulous partnership with Lawrence Berkeley National Lab. Because of these relationships that we have with both of those entities, we have access to world-class testing facilities that entrepreneurs usually can't get access to, and then providing the funding to support the testing protocols that these innovators need to move towards and accelerate towards commercialization is a really critical support for the clean energy innovators in the state of California. I also want to mention our subcontractors. We're really grateful to be working with Momentum, who is helping us with a lot of our strategy work and outreach and reporting. And then we are also working with Lacey down in LA, who were fabulous partners in helping us host our CalTestBed symposium in 2020 in December. So the benefits of CalTestBed are terrific for clean energy entrepreneurs. This project, our program, helps entrepreneurs de-risk their technologies at these world-class facilities through getting a voucher between $10,000 and $300,000. And it all depends on the type of testing that they need to be doing and the results that they are looking for from the testbed facilities. They can get this voucher for use at one of the participating test beds to cover the cost of testing and technology. I just want to note that none of this funding is going directly to entrepreneurs. The funding is going to the testing facilities to cover the cost of testing. That question comes up quite regularly, and so I just wanted to make sure I noted that. Entrepreneurs will also get a powerful network and cumulative resources of unified distributed energy resources test beds across the UC and Lawrence Berkeley National Lab systems. They'll also have opportunities to present their product and do pitches to targeted customer groups, and also to next level commercialization partners like investors and potential customers. Um, we're also providing access to experienced clean energy entrepreneurs and industry experts, prospective partners, and utilities are at our annual symposium. So I work hard all year trying to develop relationships nationwide with really excellent partners at the US Department of Energy, various utilities throughout the country, organizations like the Renewable Energy Buyers Association, which represents some of the largest clean energy purchasers, corporate purchasers in the country. And at the symposium, we feature each one of our clean energy voucher recipients, are the companies that receive our vouchers. And we provide a lot of opportunity to connect and network during that symposium as well. We also expose our companies to additional funding opportunities through the awesome platform of the Empower Innovation Network. This was also an initiative of the California Energy Commission. It's not directly connected to CalTestBed, but it is a really powerful tool that was designed and developed by the California Energy Commission to support the entire clean energy ecosystem, the innovation ecosystem throughout the state. And on this platform, there's events listed, there's funding opportunities that are not only California focused, but nationwide and even international, grant opportunities and awards opportunities. And there's also an opportunity to connect with and network and find partners on that platform as well. We also have built a really awesome community and ecosystem of fellow CalTestBed voucher recipients. And you can see all of the 26 voucher recipients are listed in our CalTestBed entrepreneur directory that's on our website. I also want to mention the very strategic way that the California Energy Commission has curated an ecosystem of regional innovation clusters. And this includes Lacey, Activate, Blue Tech Valley, and the Southern California Energy and Innovation Network. Each of those accelerators operate regionally, and New Energy Nexus operates statewide. So New Energy Nexus administers the CalSeed program, which is for earlier stage entrepreneurs than CalTestBed. But then CalTestBed is the next logical step in the pipeline of support towards commercialization. The CEC also has funding opportunities that are called Bridge and Ramp, which help entrepreneurs further accelerate towards commercialization. So I just want to note that each of these regional partners, act as channel partners for the applicants in our programs. And it's really a pleasure and a delight to work with each of these organizations. They're very supportive, and we also endeavor to support all of their efforts. So in regard to eligibility, what types of innovations will CalTestBed fund? I think this is on the minds of a lot of potential applicants. So we are looking for mid to later stage technologies that are hardware or integrated innovations. And they need to fall between technology readiness level 5 to 7. And we're looking for these types of organizations that would really benefit from laboratory level testing. So as you can see here, TRL 5 to 7 are defined as per the US Department of Energy's definitions. And these are the types of innovations that we're looking for. When we're talking about hardware and integrated solutions, we mean that we're absolutely not funding any standalone software solutions. They are not eligible for this program. The CEC has determined that hardware and integrated solutions have a much more challenging time raising funds to conduct testing, and it's a little bit harder for them, and so they needed this extra assistance. So any qualifying integrated solution must have both a piece of hardware that works in conjunction with software to deliver the technology's benefits. We also have 10 different technology categories that we accept applications in. And I know this is very fine print, but these definitions are all in our application manual online. They are also included in our CalTestBed facilities directory. But these 10 types of technology categories include building technologies, energy efficiency, energy storage, grid technologies, industrial and agricultural innovation, Internet of Things, material-based, renewable generation, transportation, and water technologies. And so we wanted to make sure that we were very clearly defining that the innovations that will be funded through this program are hardware or integrated solutions that support clean energy, innovations in these 10 different technology categories. So as I mentioned, CalTestBed is funded through the Electric Program Investment Charge, and that is, the acronym for that is EPIC. This is EPIC funded work. And so another eligibility criteria is that the applicants need to align with the EPIC goals. And the goals of the EPIC funding program, because the EPIC funds all come from a very small charge on the ratepayers of California's bills. So there's a small fraction of a charge on every single electricity ratepayer bill that goes into a fund, and that's who funds this work. And so in using those EPIC funds, the CEC is required to make sure that anything that gets funding through it reduces the costs for California ratepayers, increases grid reliability in California, improves the safety of California's energy mix. And there's also consideration about job creation and making sure that these companies are helping California transition to a clean energy economy. So that there's a very distinct California focus on the benefits of the funding. As I mentioned before, all the innovations need to fall between a TRL 5 and 7, and they all need to qualify within the technology categories as noted in the CalTestBed directory. And I also would like to note that we need to make sure that we have the capabilities to do the testing that is required for the testing protocols that the applicant wants. If we don't have the equipment, we cannot purchase the equipment to do this work. So it has to be pre-existing at one of the 60 testbed facilities in our directory. So that's another eligibility requirement. And then what kind of applicants are we looking for? So there's individuals and teams. There's businesses, which can be small startups, small businesses, and even larger companies. Nonprofit organizations with an official nonprofit tax designation. But I do want to make one note that based on experience, we are not allowing universities to apply as an entity for this program. It has to be like a business that's spun out of the university or something similar to that. And the reason for that is the CEC has determined that they want to make sure that this isn't being used just for research purposes, that this is being used to support a company that is then going to be providing these benefits to the ratepayers of California. And so that is why universities as an entity are not allowed to apply. Oh, and I just wanted to note, if anybody has questions as we are going through this, I put in some welcome information in the chat box, but please submit any questions that you have in the Q&A box in our Zoom here. So in terms of process, our process overview starts with entrepreneurs and applicants start an online application on our platform. Then the application is submitted. There is an internal eligibility review. And then once there's a pool of applications that are deemed eligible, then those are distributed to our technical reviewers. And we have a nationwide pool of subject matter experts who are technical reviewers that are really, they're matched specifically for their subject matter expertise to the applications that they are reviewing. And there's 4 specific categories that I'll go into later that get numeric scores. And that is what the technical reviewers provide input on. And it's very clear in the application manual which parts of the application are going to be scored with a numeric score and which parts of the application are part of the general eligibility requirements. Once the technical reviewers provide scores, then we determine the top scoring applicants, and those are determined and recommended in a final meeting with all of our technical reviewers as recommended applicants. They are not yet CalTestBed voucher recipients, but they are recommended to move into the next stage, which is the lab scoping consultations. And we do our best to work with the applicants and match them up with their preferred lab to have a discussion and develop a statement of work, which includes a scope, schedule, and budget. This is a draft document that is then in the next stage submitted to the California Energy Commission for review and hopefully quick approval. Sometimes the CEC has some additional questions and additional information they would like to see before approval, but that's the next stage. And then once the CEC approves the statement of work, then those are voucher recipients, and they can move on to signing the agreement package, determining the schedule for their testing, and then their testing can begin. So as I mentioned, our application apply button is on CalTestBed.com. It is very easy to find. And this will take applicants to our Smart Simple platform, where they will create a login and then submit part 1 of the application, which is very focused on eligibility. And then part 2 of the application focuses on the 4 scoring criterias, which are innovation, scalability, feasibility, and market potential. And those are the longer form questions that will require a little bit more drafting, but they're limited to 500 words in addressing each of those 4 scoring categories. In the application manual, there is a lot of guidance about what is expected in those responses, what kind of things you should consider, and what kind of things you should include in your response. So please take a look at the application manual so that you are fully prepared to answer those questions. I want to mention also in the application, you will be required to select your top 3 choices from the participating CalTestBed testbed partners. So you should familiarize yourself with these facilities and the capabilities using the CalTestBed directory. So the technical review, as I mentioned, has these 4 areas that they get scored on. There's the innovation, feasibility, scalability, and market potential. All of these categories are weighted the same way. So, a score on one has no more weight than any other. The scores will be compiled and presented to the reviewers. The top scores will be presented to the technical reviewers in that final meeting. And then the ones that are recommended from that meeting will move into that consultation process. I also would like to note that the way that we determine the top scoring applicants, we take the top scorers from each of these 4 regions in California. And so in the last round, we determined the top 6 to 8 entrepreneur applicants from each region, the top scoring 6 to 8. And we ended up with a pool of 28 companies that were recommended overall. And those 28 companies moved into the consultation process. 2 of those companies did not make it all the way through the consultation process, one because of a timing issue, and the other because they could not get their budget to fit within the guidelines for the program. So eventually we ended up with 26 applicants that were deemed to be and certified as CalTestBed voucher recipients. So the laboratory scoping consultations, I got a little bit of feedback from our principal investigators and from the campus folks that our initial time frame of 3 hours may have been a little excessive. So this year we're proposing that the consultations be scheduled for between 1.5 to 3 hours, depending on how much time the principal investigators think they need to develop that statement of work. I know that the initial development starts in that consultation process and then is refined over a series of emails and further consultation between the entrepreneur and the principal investigators. I also would like to note that the budget is not determined by the entrepreneur. The budget for the effort is determined by the campus because only they know how much it costs them to conduct specific tests and what the staff lift entails and what the costs will look like. And so the entrepreneur talks with the principal investigators about what their needs are, and then together they determine what the testing protocol is going to look like. And then the campus is actually the entity that determines the final budget. And as I mentioned, so this draft statement of work goes to the CEC. They review, ask any clarifying questions, and if they have none, then it gets approved. And then things move into the agreement signing stage, and then the testing can begin. And so for this year, our important application dates include the following. So the applications opened on February 25th. On March 19th at 11:59, they are closing. Our initial eligibility review process will happen in that 9-day period between March 19th and March 29th. And then in March 29th, our technical reviewers will begin their review process, which will end May 14th when we have our final technical reviewer meeting in which we get our final recommendations. Then my team at New Energy Nexus will be, organizing everything and working with the campuses to ensure that we have everything ready to start the consultations, which will start the week of June 21st. Now, this consultation schedule is weeks long, so that we provide the campuses enough breathing room for them to schedule these things. Some campuses get multiple projects, and we don't want to stress out our principal investigators or the ombuds people working at the labs with us. So we have a wide time frame, but I also want to note that once the labs and the entrepreneurs are finished and have a draft statement of work to submit to me, I have a rolling deadline where I bundle the applications or the statements of work, and I send them in bunches to the CEC. So there's a rolling review process. We don't have to put everything on hold and wait till the end of the consultation process to submit for review and approval. So if statements of work are completed earlier than at the very end of this time frame, they can get reviewed and approved and start moving before the end of the consultation period. We tried to build in as much flexibility into this program as possible because we recognize that our partners are not only doing CalTestBed, they have many other projects that they're working on. And many of them are also conducting lectures and teaching and doing all kinds of other work at the laboratories. So we're trying to provide as much flexibility for our principal investigator and ombuds partners, but also we recognize that the entrepreneurs are still working to try to build their business and acquire customers and submit other grant proposals. So we're trying to make sure that everybody has time to do everything that they need to do. And then, as I mentioned before, once all the agreements are signed and a schedule is finalized, that's when the testing can begin. And speaking of agreements, here is a very basic overview of our agreement structure. So the California Energy Commission has given CalCEF, which is New Energy Nexus, a grant to administer this program. My organization has separate agreements with each of the 9 UC campuses that are working on this, and with Lawrence Berkeley National Lab. So there is an agreement called the User Agreement for Test Beds, and we have all of those signed and all of those are complete. Once we get the applicants that are ready to go and signing agreements, the next stage for them is to sign a user agreement for entrepreneurs. And that user agreement for entrepreneurs is between the testbed facility, like the campus, and the entrepreneur. That will have the signed statement of work that's been approved by the CEC attached as an addendum to that, so that the testing protocol, the budget, everything that was developed in that SOW process, that is attached as an addendum to this user agreement for entrepreneurs. Then the next stage is that the entrepreneur signs an agreement with my organization called the Voucher Recipient Agreement. And that also has that signed statement of work attached as an addendum. And so that addendum ties all of these agreements together, and this is the agreement package. So the entrepreneurs will be signing 2 documents to make sure that they are prepared and ready to continue and move along with their testing. And now I am sharing just some applicant resources. These are links to the application manual, which really gives a very full description of what's expected in your application. Every single application question is in this manual. So if you want to start by just reviewing the manual before you even log into the system, you can do that and get a really clear overview of everything that we're going to ask you in the platform. And if you want to start drafting in like a Word document to work on it before you submit it through the system, you can do that as well. Here's also a link to the facilities directory, which lists all 10 of our participating campuses and the 60 different testbed facilities they're in and the capabilities of those testbed facilities. There's also contact information for the campuses in there for the ombuds people. I just would like to note that if you are going to contact an ombudsperson, they have been giving guidance. They are not to help any applicants fill out their application, but can give guidance as to whether or not there's certain capabilities at their campus. So please do not contact the ombuds people asking them for help in how to word your application or how to present your testing within the application. But you may reach out to ask very targeted questions as to whether or not there is the capability to do XYZ at their campus. Do you have this piece of machinery? Do you have this capability? That's okay. We also have a link here to a video which gives a click by click how to set up your account login. And when you go to apply, this image in the bottom right hand corner is exactly what the screen is going to look like. You're going to create a login through this screen, and you're going to be able to use that login to go back into your application if you don't finish it initially. And you can go in and check it before you submit it. So please make sure that you follow all the instructions. And if you have any problems at all creating your login, please feel free to check out our link here to how to set up your login. And with that, I am going to stop sharing my screen, and I'm going to throw it over to Fred, who will talk about some of the capabilities at the UC Berkeley campus.
Sounds good. I'll share my screen then. Let's see, it says host disabled participant screen sharing. So maybe.
Okay, let me see if I can.
You can make me a host or something.
Go in here. Okay, you should be able to share your screen now.
That looks right. All right.
Perfect.
See if we've got it here. Yeah. Okay, great. Thanks a lot, Tenley. My name is Fred Bauman, and I'm a project scientist at the Center for the Built Environment at UC Berkeley. And I'm also serving as the ombudsperson for the CalTestBed project at Berkeley. And so it's my pleasure here today to give you a brief overview of the capabilities that we have at the Berkeley campus to support the CalTestBed testing program. So let me just start off with a couple quick words about my research organization called the Center for the Built Environment, which is the main testing group at Berkeley. We've been around for more than 20 years, and we are set up as a consortium with leading building industry companies who serve as our advisory board. They give us feedback on our research, and as a result, we are very much grounded in the real world. You know, we find that the companies that serve as our partners, many of them, a good chunk of them, are architectural and engineering design firms. So they're interested in understanding about new technologies and how they can help design energy efficient and better buildings and so forth. And so we have to pay a lot of attention to, you know, real world problems, practical guidance, developing tools that help them design better buildings. And so as a result, the work that we do is really grounded in real world conditions. As you can see on this slide, you know, our main research areas include a lot of work on building HVAC systems, a lot of measurements of indoor environments, also referred to as indoor environmental quality. We do a lot of thermal comfort research, building facade systems, and a lot of emphasis on human factors is always a part of our research, because it doesn't matter how efficient a building is, if the people don't like it, you know, it's not really going to serve its purpose. So we always try to pay attention in our work to having the buildings, not only, you want them to be energy efficient, but you want them to serve the people that are occupying them as well. So one of the, in our research on building HVAC systems, we do a lot of work in field investigations and fully operational buildings. This can provide a lot of very practical information on how your invention, your device, your control strategy, your integrated system, whatever it is, how it functions in a, in a real building. It's one thing to do it in a kind of a small scale lab, but you can really get a lot of valuable information in full scale buildings. So this slide just shows you that we've done a lot of field studies, and we've used a lot of different approaches, controls intervention studies, and indoor sensing and so forth. I'll give a few examples here in the next couple slides, but did want to point out that over the course of all these years of testing, we've investigated a whole range of building system types. So you've got your conventional, and this is, heating, ventilating, and air conditioning systems that I'm referring to. So variable volume with reheat is, a very conventional system that a large majority of buildings use. We've done a lot of work with those, but we've also investigated more innovative and advanced building system types like radiant systems, underfloor air distribution, displacement ventilation, mixed mode with natural ventilation, and even personal comfort systems. And these systems are attracting more attention in recent years as people are looking for ways to really improve the energy efficiency and improve the comfort of the people in the buildings and so forth. The pictures here on the screen are really taken from a recent project we finished up that was also funded by EPIC on radiant systems, and we had studied these 5 buildings in the California area. And so that was one example there. Another bit more on field studies, there we have one of our facilities on the UC campus is actually a campus building called Siddharjadai Hall. And this building houses the Center for Information Technology Research in the Interest of Society, better known as CITRIS. They are another one of the participating organizations on campus along with CBE. So the two of us, CITRIS and CBE, form the UC Berkeley research group that is providing assistance and testing capabilities for CalTestBed. This building is really quite something because it's a fully instrumented, monitored advanced system with best practice VAV system and so forth. So it really is a as it says, a living lab in which you can conduct fairly detailed studies. And the advantage, of course, for us is that because it's on campus and we have access and we know the building manager and everything, it gives you a great ability to conduct studies and gain access to the building and get the data and analyze it and everything. So we've actually used this building to conduct several of these kind of controls intervention studies. So it's a great example. And, if you had a device or an integrated solution or something that, would want to be applied in a conventional building, this building here could be a great example of where we could install it and have access and study it over the course of many months and get an idea of how it performs in comparison to a standard control approach, for example. And here I wanted to actually give an example of that. This is an example of a study that we did in Siddharjadai Hall on a technology. It's for conventional air distribution systems called time average ventilation. And without getting into a whole lot of detail, the basic concept is that it's trying to save energy by reducing ventilation airflow rates into zones of the building by providing a more advanced control method. And it turns out that the background on this is that most building control systems have put in way too much air into the building. And it's a kind of a criticism of some of the devices that are used. Are called VAV boxes and so forth, and they don't allow the airflow rate to go down low enough. So as a result, you're blowing more air into the building, which takes more energy, more fan energy, more cooling energy, all this stuff, because you can't get it lower. Well, with this method that we investigated, we were able to actually get it down quite a bit. And you know, the graph shows this. I don't want to, you know, get into it. I just mainly want to talk about it. But what we were able to do over the course of several months is to compare sort of the baseline standard control approach with this new approach that we would implement, and collect the data and analyze it. And you can see in the last bullet there that we showed 15% reduction in fan energy, 41% in reheat energy, and 23% in chilled water energy. So it was a dramatic improvement. And this is the kind of thing that a study in a full-scale building with these intervention studies can do. It can be a very effective proof of concept with real data over a course of, you know, many months that is very, very, very valuable. I will say one other thing, although we didn't use it in this particular study, we've developed a really cool new method, which is a randomized intervention study, in which when you're comparing one baseline control approach versus a new or advanced approach, you have a way where each day you randomly choose one or the other. So it's not something that you preordain or plan out. It just is done randomly. And over the course of many months, this ends up giving you a very fair and reasonable comparison, because you're not affected by whether it was colder this week and hotter the next week and all this stuff, because it's all random over the whole time, and it switches back and forth between one and the other. And you measure the performance with one versus the other as it comes along. So it's a very slick way that our researchers have learned how to do this, and it's a great way. And we've done several other studies with this method that, you know, we can share with you if interest is there. All right, enough on the details there. Another thing that we do on our field studies is get in there with a lot of detailed monitoring. And this is generally we call it our wireless toolkit. You can see some of the images on the lower left there of these boxes with multiple sensors for measuring all sorts of indoor environmental parameters. And, you know, you can collect data from a standard building automation system, but it's kind of limited, you know, like a thermostat on the wall or an airflow in a duct or something like that. But if you really want to understand the details of the indoor environment at a greater detail to understand how it affects people and their comfort, a more detailed array of sensors can be placed and report back wirelessly. And this data can be collected in real time and give you great value in understanding how the building is doing. So we have a bunch of these sorts of things that we use in our field investigations as well, if that's the type of study that people are interested in. Now, switching to lab studies, in the lab studies, we've studied all kinds of things from comfort, thermal comfort, air movement, air quality, even wearable sensors, and I'll say a few words about automotive cabin conditioning systems. We do both human subject experiments and then just physical testing in these. It's a controlled environment chamber. And so human subject experiments would be, as say, an example there is a picture in the lower right where you've got subjects sitting there and being exposed to certain conditions. And then they're telling you through surveys, how do they like it? Is it too hot, too cold, too breezy, whatever it is that you're testing. So you can test a bunch of devices with human subject testing, or if you just want to do physical testing, you can, you know, just get a whole array of sensors for air quality or temperature and so forth that allow you to characterize that, ventilation studies and so forth. The top left picture is an image of a subject in which we're looking at air quality measurements in a very dense array of locations to study the breathing area around a person and what happens to pollutants that are breathed in or exhaled and this kind of thing. So there's a whole range of things there. Moving on, here's I want to say a word about the controlled environment chamber. This is our main test room that we do these studies, both the human subject ones as well as the physical testing. And it's really designed to resemble a realistic contemporary office space. And so, in that sense, we're trying to make it, when people are in there, they think they're in a real space, and you get more realistic responses from the subjects. But again, it's a very real world kind of a thing. We're setting up realistic air distribution systems. We might have underfloor air with air coming out of the floor grills, or a radiant system from the ceiling, whatever it might be. We actually set it up, and it's representing a real situation. And the one other thing I should mention, in the lower part here, you can see images of the thermal mannequin that we have. We have this advanced skin temperature controlled thermal mannequin that actually measures the heat exchange between a human body and the environment. And this can be used for characterizing devices that are being used for conditioning an individual, or how that person experiences more of a system. And so you can see just those are infrared images there showing the temperature distribution on the mannequin itself, and it represents a real person by heating itself up so that the skin temperatures represent that of a person. So that's a very useful instrumentation there as well. Couple more slides here and then I'll be done. The automotive cabin studies, all of our thermal comfort research, is focused on people in buildings, but we also got a lot of interest from the automobile industry. And so we have actually mocked up full-scale cabs in our chamber to study space, conditioning systems that would be, for example, installed in an efficient electric vehicle. And you can imagine an electric vehicle where energy is going to be at a premium. You don't want your heating and cooling system using tons of energy. You want it to be as efficient as possible. So this was a way to study some of these more efficient methods for conditioning people and getting both human response with human subject testing, as well as putting the mannequin there to study the detailed heat exchange and more detail there. So there's a lot of ways you can do flow visualization, infrared imaging, and so forth. And there's also a full advanced Berkeley model on thermal comfort that has been developed that we use for simulation studies, and that can support all of this work as well. So there's a lot of ways to get at that type of detailed comfort investigations in a small space like an automobile cab, where you've got air blasting in you and the sun coming in the window and all these kind of crazy things. It's quite interesting. And then finally, one last, I was talking to Tenley about this earlier. We do have a boundary layer wind tunnel on the UC Berkeley campus. This is a facility that models the characteristics of natural wind flowing across the Earth's surface. And so as you can see in this image, the blocks that are placed on the floor of the tunnel are representing the kind of the turbulence that is caused by trees and buildings and obstacles, whatever the wind encounters as it flows along. So you develop the proper modeling of what's called a turbulent boundary layer. And then when you place your buildings or device or whatever it is that you want to study in the wind tunnel, you've got the proper modeling of full scale. And so we do studies of buildings, airflow around buildings or through buildings, but also because the tunnel is quite large, it's 5 feet high and 7 feet wide, you can fit anemometer devices, airflow measurement devices, and do side-by-side comparisons if that's something that would be of interest in developing innovative velocity measurement systems. We've done some of that in here. So that's just a couple of examples of the things we have at UC Berkeley. And if you've got any questions, you can feel free to contact me, or you can get a hold of me some other time later on, and I'd be happy to help out as best I can. So thanks a lot, Tenley.
Brilliant. Thank you, Fred, so much for going over some of the awesome capabilities that you have at UC Berkeley. I see that there's 3 questions in the Q&A box,
Okay.
and so I want to make sure that we address those. The first question is asking whether or not the national lab's working with us, and it's at present, it's just Lawrence Berkeley National Lab that's working with us. But they're asking if there are UL or NRTL certification capabilities there. And I just want to note that we do not, through CalTestBed, we do not provide certification. But I would encourage you to reach out to, if you're planning on applying with Berkeley National Lab as your #1 proposed lab to work with, ask them if they are able to conduct third-party testing that would simulate the certification testing standards that you're looking for. With this program, the UC campuses will not provide verification or certification, but they will provide third-party testing feedback. And that is because of legal concerns and risk avoidance, because they don't want to certify a product that will then be put in the grid and then be held accountable if that particular product created an issue. So we will provide the testing, but we can't provide the certifications yet. I am looking into future iterations of this program to see if potentially at some point we could provide certification as part of the effort, but at present it is not. The next question is, what if our integrated technology falls under multiple technology categories and types? Can we select multiple categories or only one? I think in the application, it's just limited to one. So if you look at the definitions of each type, figure out which one it best fits into. I know for, building technologies and energy efficiency, there's a lot of overlap there, but whichever one best describes the type of technology that you are working on, that would be the one that you should choose. And then in your description, you can provide a broader explanation of what the technology is. But for our own purposes, we need to categorize them by certain technology types so we can match the correct technology or technical reviewers to review the application. So that's why we categorize them that way. The next question is there a criteria on size of business? For example, a maximum annual revenue or equity financed in order to be eligible for the program? And we do not have that kind of criteria. We don't have a cap on the, amount of revenue that a company has. And so that is not an issue for eligibility here. And then finally, this is specifically for you, Fred.
I see one for, let me
Yeah.
take that one. Do you see a role for better weather forecasting and optimizing HVAC operation? This is from Christopher Lund. And I would say, that is we know that weather forecasting is going to be playing a role, as we deal with climate change and all this kind of thing. So there's long range forecasting where people are doing studies and all this kind of thing. I'm not sure if that's exactly what you're referring to. I do know in the work that we've done with what we call high thermal mass radiant systems, which is a technology in which tubing with water is embedded in concrete slabs and so forth and heated or cooled to control the building. And so because of the mass of those buildings, anticipating what's going to be happening 1 day or 2 days in the future actually can impact what you should do with controlling that building, because the thermal mass is quite, it's kind of like wrestling with a 50-pound gorilla or a 50-ton gorilla, whatever you want to call it. So you do need to pay attention to those kinds of things. I'm not sure if that's what you're referring to, Chris, but I think that there's definitely interest in this sort of thing. And they are more advanced controls for buildings are, looking at how do we incorporate, what the forecast is for tomorrow? Do we just need to know the temperature, or do we need to know 5 days from now, or something like that? So there's definitely a role for that. And whether or not, I don't know if it's something to be more detailed about it. I don't know if what we have already is good enough, or if there would be something that you could improve on, but it's definitely important, I would say. That's the answer.
Excellent. I don't see any additional questions that have come in, but I do want to note that in the chat, I've added a lot of resources with the links and all of the information in there. Let me just check to make sure I haven't missed anything that's in the chat. Nope. So there's links and resources in the chat right now with the application link and the application manual link and the directories link. And in closing, I just want to say, Fred, thank you so much for your time and your energy and your help with this program. We're really deeply grateful to our UC partners. There's such an excellent bunch of experts and scientists and administrators, and it's a huge lift to manage this program. And we're really grateful for the ombuds that are taking on the responsibility of helping kind of traffic cop all of the questions and all of the agreements and all of the work that's being done on all of these campuses. So Fred, thank you so much for your time and for your expertise. And we will be having one final webinar tomorrow. And I'm really excited to be talking about the UCSD capabilities tomorrow. And our friend Mike Ferry is going to be presenting that. He's one of the fantastic PIs at UCSD, and he's going to be presenting the capabilities there. So if anyone is interested in tuning in again to hear more about the UCSD capabilities, please feel free to join us tomorrow. And we're also recording all of these, so we will be presenting all of them and posting them via social media as well. So thank you all for your attendance, and take care. Have a great afternoon.
All right. Thank you.
All right. Thank you. Bye-bye.